Keenumbers.
Hey, I'm Keenum. Let's talk about centimeters and meters.
Looks like Hezzy is measuring not just with centimeters, but he's got his tape measure in inches as well. Are you ready to measure the Triceratops in centimeters? We can do both. Okay, his tail starts over here at 0. Good job, Hezzy. Oh, we gotta move him back a little bit so we can see. Is that right? Is his tail lined up with 0? It's pretty close. How long is your Triceratops?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
Looks like he's 18 centimeters. He's pretty tall. Okay, how many inches is your Triceratops? Let's put him back over here for reference. And then you can use your tape measure and we'll figure out how tall, or rather how long he is. Are you ready? Okay, use your tape measure and see how long he is, and that way we can see in centimeters and in inches how long that Triceratops is. How long is he in inches?
7.
Looks like he was about 7.5. Try again. Remember, start this part right at the tip of his tail. Oh, I think you're right. He's closer to 7, maybe 7.5 inches. That's okay. We are estimating.
The jet is.
Let's see how long your jet is. How many centimeters is your jet?
You gotta get these 2 fins at 0.
That's right, you gotta line it up with 0. How long is your jet?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 centimeters.
About 13.5 centimeters. Okay, let's see how long your jet is in inches. There you go. See, Hezzy is lining up the tape measure with the very edge of the jet.
6.
Looks
About
like
5.5.
5.5 inches. Or, as you said earlier, about 13.5 centimeters.
Meters are in every kilometer. The metric system that's used everywhere on God's green earth. Cross the Colorado in a gondola. Hike the highest mountains outside of Nepal. Swim the English Channel faster than Phelps. Yellowstone to ride a buffalo. 2.54 centimeters are in an inch. 12 inches in a foot and 100 centimeters in a meter. 1,000 kilometers. That's a lot of kilometers. The metric system that's used everywhere on God's green earth. I'm gonna swim outside of Guam. I'm gonna hike the Wasatch Mountains with anchovies. Gonna get a bungalow on the dark side of the moon. I've run out of lyrics to sing in this silly song. 2.54 centimeters are in an inch. 12 inches in a foot and 100 centimeters are in a meter. 1,000 meters are in every kilometer. The metric system that's used everywhere metric system.
As he says, it's a rocket ship. We put it here at the 0, and then we take a look. It looks to be about 12 inches.
Yeah!
It looks to be about 12 inches. Yep, not inches. Excuse me. Whoop, centimeters.
Let's see how long my jackhammer is.
Let's see how long your toy jackhammer is. It's probably longer than our measurement here, our tool, which is just a clipboard, which conveniently has centimeters built in. It's too long. Wah, wah, wah. But we can use the power of addition to figure out how long it is.
Oh yeah, addition.
Let's break it up into pieces. Okay, we line that up with the 0. Probably easy to do right here.
Another jackhammer.
And then we can see it is about 21 and a half centimeters. 21 and a half centimeters. And then each of these orange pieces, we have 2 orange pieces plus a blue coupler. This piece is about
Let's see how long this jackhammer.
21 and a half inches. Hold on. If they're both 21 and a half, not inches, excuse me, centimeters.
Let's see
All right.
how long this jackhammer.
All right, let's wait. Let's finish this one. If this is 21 and a half centimeters, and this is 21 and a half centimeters, what's 21 and a half plus 21 and a half? Well, what's a half plus a half? 1 whole. So 21 and a half plus 21 and a half is gonna be 42 plus a whole, that's 43 centimeters. So this portion right here, you can't even see it. It's so long. It's 43 centimeters. And then you add the length of the top handle for this toy. We said that's also about 21 and a half, or maybe it was 22. Let's take a look again. Looks to be about 21, 22. We'll just round up. It's pretty close to 22. 22 centimeters plus 43 centimeters. Well, what's 22 plus 43?
72.
No, what's 22 plus 43?
22 plus 43. 22 plus 43. 20 plus 40. Well, that's 60. 65.
65 centimeters, that's correct. So this long toy is 65 centimeters. And that's how, when you only have 30 centimeters of runway here, you can use the power of addition to figure out how long it is. Okay, let's get your next toy. He wants to look at another tool here. It's gonna be similar. Womp, womp, womp. It's too long, so let's use the power of addition to figure out how long it is. All right,
Let's break these into smaller pieces.
you wanna do the top handle here?
Yeah, let's do this top hand.
Okay, how long is the top handle? You tell me.
Yes, sir. 20.
It is about, yep, 20 centimeters, good. And how long is this portion here? Well, we just measured this one. This one is 21 and a half centimeters. So what is 20 plus 21 plus a half? What's 20 plus 21?
20 plus 21? Well, that's 41.
That's 41, and then you add a half. 41 and a half centimeters. That's how long this toy is. 41 and a half centimeters. Woohoo! Okay, what's next? Hezzy wants to do a stinky sock. Ew, a stinky sock. It's even got dirt on it.
Ew!
Okay, stinky sock.
Ew!
It looks like it's my sock. A stinky sock, my sock, is about, help me out, swordfish. How long is this sock? Oh, it looks to be, oh. Well, I'm gonna call it a swordfish because he looks like a swordfish. He's about 24 centimeters. I mean, the sock, the stinky sock is about 24 centimeters. No, don't smell the sock. Ew. Let's see how long this blue dinosaur is. Put him over here by the 0.
5.
He looks to be about 5 centimeters. Very good. And again, you can put,
How long this big weight is?
oh yeah, how long is this water baton? What do you think?
This is 7, 8, 17 and a half.
18, 17, 17 and a half centimeters? Okay. 17 and a half centimeters. Now,
Ooh.
this is important, guys. You can start this measurement anywhere. Stinky socks, get out of here. You can start at the 10, and then it goes over here to 27 and a half. Well, 27 and a half minus 10, hey, that's 17 and a half, which is exactly what you would hope to get, because when we started at 0, it was clearly 17 and a half centimeters. If I've said inches, I'm sorry. I mean centimeters. I'm gonna create a lot of work for myself if I have to go back and redub some of this or beep out parts where I said inches. We measured this toy earlier. Let's see how long it is instead of how wide it is. Line it up at the 0. How long is the wingspan? Or how wide is the wingspan?
6.
It's about 6 and a half centimeters.
Let's see how long this jet span is.
Oh yeah, let's look at the jet's wingspan. What do you think?
Whoa, that's long. It has 14 inches.
It's not inches. It looks to be about 14.
Let's see what this second wing.
Hold on. We didn't finish. It looks to be about 14 and
A half centimeters.
almost 15. It's really close. Okay, you want to figure out what about the tail here? All right, line it up. What do you think? How many centimeters wide?
5.5.
It's about 5.5 centimeters. Woohoo!
Hey, how many meters are in 2 kilometers? That's right, 2,000 meters are in 2 kilometers. Mom, Dad, grandparents, if you find this work that we are doing invaluable, go ahead and send us a thank you. There's a link below. You can buy us a coffee. That will allow us to expand and reach more children with math that's going to empower them to problem solve all the days of their life. Let's reinvent math education together. God bless.
The squid! Squid. Okay, let's go, squid. No, not the tape measure. Come here, squid. How long are these squid toys? Looks to be 12 centimeters. Yeah, 12 centimeters. Squid.
Let's see how long this purple sword shirt.
Now get the stinky sock out of here. Stinky socks. Don't smell the stinky socks.
You smell it.
No. Let's see how long this marker is. I'm surprised a banana hasn't shown up yet.
Marker.
Let's see how long this marker is. This marker is spot on, 13 centimeters. And again, if you started it at 5 centimeters, for example, 5 centimeters to 18 centimeters, that's a difference of what the is going on here? Bananas! Well, let's see how long one banana is. Okay, let's be very careful. We don't want to bruise the bananas. Let's see how long that banana is. Hey, what's going on here? We want to see how long the banana is. Don't sit on the bananas. Banana! Okay, let's see how long the banana is. He looks to be, wow, he's almost 19 centimeters. He's a long banana. I don't want to smell stinky socks. All right, watch out, Maggie. Don't hit your head. No stinky socks. This banana is about 19 centimeters. He's pretty long. Banana! Banana. Flying banana. Goodbye, bananas.
Keenumbers. Keenumbers.
I'm Keenum. Let's talk about multiplication word problems. Let's talk about multiplication word problems. First up, Hezzy has 3 trains and Baggy has twice as many. How many do they have? Hezzy has 3 trains. 1, 2, 3. 1, 2, 3. And Baggy has twice as many. What does twice as many mean? That's right, 2 times or 2 3s. Twice as many. So he has 3 and 3 more. Twice as many. How many do they have? Well, let's see. We have 3 plus 6. What's 3 plus 6? Too easy. They have 9 trains. 1, 2, 3, 4, 5, 6, 7, 8, 9. They have 9 trains. Woohoo! Okay, let's do some more multiplication word problems. The Greater Gator ate 7 pizzas. That is a lot of pizza. Boy, you sure must have been hungry, Greater Gator. Each pizza had 6 slices. Yep, I see that. 6 slices. How many slices did the Greater Gator eat? If he had 7 pizzas and each pizza had 6 slices, how many slices did the Greater Gator eat? 7 sixes, right? Yeah, because each pizza had 6 slices. That's a lot, Greater Gator. Hey, Greater Gator, don't eat the pizza, right? You've already had 7. If the Greater Gator had 7 pizzas and each had 6 slices, that's gonna be 7 by 6. Or 7 sixes, which we know is 42. That's a lot of pizza slices.
Step 1, stare at the problem, young woman, old man. Step 2, you may panic, yes you can. Step 3, you may cry, even if you don't know why. Step 4, you should press on, yes you should try. What problems they're challenging you? What problems they're making you blue? Step 1, step 2, step 3, step 4. What problems they're troubling you? Step 1, stare at the problem, young woman, old man. Step 2, you may panic, yes you can. Step 3, you can cry if you don't know why. Step 4, try to solve it, yes you should try. What problems they're challenging you? What problems they're making you blue? Step 1, step 2, step 3, step 4. What problems troubling you? Step 1, stare at the problem, young woman, old man. Step 2, you should, yes you can. Step 3, don't dare cry, I'll tell you why. Step 4, you can solve it, press on, let's try. What problems they're challenging you? What problems making you blue? Step 1, step 2, step 3, step 4. What problems troubling you?
For every soda that Pirate Sam drinks, he burps 5 times. If he drinks 4 sodas, how many burps will he have? That's 5 sets of 4, or 4 sets of 5.
20.
That's right, he's gonna have 20 burps. That's a lot of burps.
Whoa.
Hezzy can earn 25 cents. Boop. That's 1 quarter. if he cleans up his toys. If Hezzy does this for a week straight, how much money will Hezzy have? How many days are in a week? That's right! There are 7 days in a week, so he'll do it 7 times. 1, 2, 3, 4,
25,
5, 6,
50,
7.
100, 125, 150, 175, 200.
Close. Not 8 times, 7 times. So 25 cents, 50 cents, 75 cents, 100 cents, 125 cents, 150 cents. Hey, Hezzy was right the second time, 175 cents. So that is also known as $1.75. $1.75. And since $1 is 4 quarters, you could get rid of the 4 quarters and simplify and say that Hezzy will earn $1.75 for cleaning up his toys in 1 week.
Here's $5.
That's a bonus! No, you don't get $5 for doing it.
If I have 20 pairs of stinky shoes, and each pair, well, that's 2 shoes, how many stinky shoes do I really have? That's right, 40 stinky shoes! Ooh. Hey, Mom, Dad, if you want to support this channel, you can buy us a coffee. The link is below. See you next time. Hey, don't forget, God loves you.
A toy brick toilet can be made with 22 bricks. Made out of toy bricks. 22 of them.
Ew.
Each brick has 8 dots. 8 dots. It's a 4x2. 8 dots. How many dots total are there? How many dots total? Well, if we have 22 bricks and 8 dots each, that means we have 22 eighths. 22 times 8. This one is kind of advanced. Well, what's 8 20s? That's right, 8 20s is 160. And what's 8 2s? That's 16. So 160 and 16 is 176 dots. The toy brick toilet, toilet, it has 176 dots.
Keenumbers. Keenumbers.
I'm Keenum. Let's talk about 3-dimensional shapes.
The cube is the first one on our list. The cube. I got 6 sides, I'm not a rube! The cube. The cube is made up of 6 squares. Every side is the same. That is what's so special about the cube. 6 equal sides, and each side is a square. That's a cube. When you put them all together, bada bing, bada boom. The cube. I'm the cube. I got 6 sides. I'm not a rube. The cube. What about a rectangular box? Now, we have a very fancy name for this that we'll talk about later, and that is the prism. But you can also have a box, which is what we most commonly say here in the Western world, that is not a cube, but yet it is 3-dimensional. This would be a rectangular box. And don't worry about that word prism. We will talk about the prism last. Here's a rectangular box. It looks like a cube. It looks like 2 cubes, but you can have a really long rectangular box as well. Boop. There you go. That's the benefit of magnets in this illustration. We can just make our own rectangular box. And in some sense, this is kind of like a 3x1 box. Ooh. Rectangular box! Yeah!
Spheres and cubes and spheres and cubes and spheres and cubes and spheres. Like the prism and the cylinder too. The pyramids are awesome and I wanna visit one. I gotta do more shapes with you, but I'm out of time. We'll have to catch up later and finish this rhyme. 'Cause spheres and cubes and spheres and cubes and spheres and cubes and spheres. Mobius strip.
Let's talk about the sphere. This will remind you of a circle, and there is a lot about a sphere that is related to a circle, but that's advanced, and that's a conversation for when Keenumbers is servicing not just K through 12 education, but even college mathematics. Let's table that. The sphere is better known as a ball. I probably should have wrote that with the Sharpie. On the spot correction, aka ball. Also known as a ball. That's a sphere. The sphere. Also known as a ball. It's a three-dimensional shape. It's not flat. That's what we mean by 3D. See, 3D, that means 3 dimensions. It's no longer just length and width, but now we're talking about height. 3 dimensions, length, width, and how tall it is, height. That's what 3D means. It means it's not flat. Like a pancake. Ooh, the pyramid. If you want to build your own pyramid, you're going to need to pause. Step 1. Step 2. What did we say? 4 triangles, 1 square. Step 2 is you're going to make the square the base of the pyramid. And then you take your 4 triangles and you slap them together like that. Bada boom, bada bing, Bob's your uncle. This is a pyramid. You'll recognize these from the history books. In Egypt, there are still some pyramids standing today. That is awesome. The pyramid. This pyramid has 4 triangles and a square base. And what's so special about these triangles? This is an equilateral triangle. Equilateral, that just means all 3 sides are equal. This side is the same as this side, which is the same as this side. Equilateral triangle. Cylinders, prisms. We could even talk about the cube. 3D shapes are so fun, and we'll do more shapes on this channel because you know what? God has filled our world with so many different, colorful, and interesting shapes. We should learn about them. Hey, Mom, Dad, if you like this content, if you think it's educational, and maybe even a little fun, go ahead and buy us a coffee. There's a link down below. It takes less than 5 seconds. Thanks so much. Hey, class, don't forget, God loves you. Now, the cylinder is basically just a circle that is tall. Here's an excellent example, real world application. This is a circle that has height or depth to it. And that's why we call it a cylinder. So this is a very common object that you can find in your house or in an office setting. We can even make our own cylinder. All you need is a piece of paper. Grab your piece of paper. If you want to make a cylinder, take a rectangle or any piece of paper will do because most of our paper is in the shape of a rectangle. And you want to grab the length of the rectangle. That's the long side, not the short side. And make the 2 edges come together. And then boom, we've got ourselves a cylinder. It's a circle that has this extra dimension, the third dimension of length. And then you can just take a piece of tape. Hey, speaking of that cylindrical shape, the roll of tape. Once you got your tape in place, you're good to go. You have now created a homemade cylinder. And it's not very complicated. What's another shape that you can find around the house that is cylindrical, i.e., that means it is in the shape of a cylinder? That's right! Green beans! Don't forget about our friend, the can of green beans. Most any fruit or vegetable can will be in the shape of a cylinder. Green beans! The greatest of all canned vegetables. Green beans. Okay, the next shape is something you already see sometimes when you're out and about or at home, the donut. But its proper mathematical name is the torus. Some people will know the torus as a car. Well, yes, it is the name of a car, but more specifically, it is the official name of the donut shape. And I just did this with a hodgepodge of Play-Doh. What's so special about the torus? The torus can be made by taking two ends of a cylinder and coming together. So all you gotta do with your Play-Doh is roll it out, roll it, roll it, roll it, roll it out. And then once you've got a good shape, this is cylindrical, you just take the ends together and you've got a torus, or the donut. Torus. This is the Mobius strip, or as an amateur student of German, I believe it would be Möbius. And I'm not even sure it's a German word, but in the West we say Mobius strip. It's formed by taking a flat rectangle, and of course a rectangle is flat, but I'm just emphasizing that it's flat. Instead of connecting the two ends together to make a cylinder, you add a half twist. Whoa. Step 1, get your focus set. Step 2, take your rectangle and give it a half twist. Half twist, that's it. Not a full twist, just a half twist. And now, with half a twist, you're gonna connect the edges together. And that is our Mobius strip. Step 3, get some tape to hold it together. Now we have our Mobius strip. What's so special about a Mobius strip? It has no inside and no outside. If you take your finger or a car and you run it along what you think is the inside, well, what do you know? You end up on the outside of the Mobius strip. This is a really cool shape. Last but not least, we're going to talk about the prism. Now, this has a very difficult definition, but the easiest way to think about a prism at our level is just to have a simple shape like a square or a triangle and then stack them. The prism is formed by taking the same top and the same bottom. And in this case, this is a really simple prism. We just took a bunch of squares and stacked them together. That forms a prism. But what about with triangles? You can do the same with triangles. We have the same top and the same bottom, and when we stack a bunch of them together, we have formed a very simple prism. We can do the same with these isosceles triangles. Two sides are the same. That is our isosceles triangle. We have the same isosceles triangle up top as we do on the bottom. And so when we stack these all together, we've formed a very simple prism. But you can make a prism with a parallelogram as well. And it can even be slanted. Take a look at some of these prisms. Whoa, they're not perfectly straight. It's like they're pushed. But they're still the prism because the
Keenumbers.
Hey, we're gonna learn how to subtract with negative numbers. Mom, Dad, this is different than anything you and I were taught as kids.
Like 137 donuts minus 68 donuts.
What? 37 minus 68?
All right. Do you want me to write or do you want to write?
I think Pirate Sam wants to subtract.
Pirate Sam, are you going to help us?
Yeah. What is 100 minus 0?
Well, 100 minus 0. That's still 100. But what about 130 minus 60? Or even just 13 minus 6, Pirate Sam? What's 13 minus 6, Pirate Sam? All right, Pirate Sam, what's 13 minus 6?
13 minus 6, which is 7.
That's 7, correct. All right, Pirate Sam, what's 7 minus 8? 7 ones minus 8. And really, this is 130 minus 60, so we got 70 here. But now we're going to look at 7 minus 8. Again, we have 130 donuts minus 60 donuts. That's 70 donuts. But now, what's 7 minus 8 donuts?
Negative 69.
Negative 69? No, what's 7 minus 8 donuts?
That's negative 1.
Negative 1, very good. So what's 70 minus 1, Pirate Sam?
I said 69.
You said negative 69. So Pirate Sam ate a lot of donuts, but there's still 69 donuts left over. All right.
Pirate Sam likes to subtract whenever he can. Pirate Sam, fiercest pirate in all the land. Pirate Sam, a one-eyed puppet mustache man. Pirate Sam, negative account balances, he's on the lam. Pirate Sam, what about that Pirate Sam? Pirate Sam.
Let's do 348 Legos minus 168 Legos. Ooh, this looks challenging. Okay, well, what is 300 minus 100 Legos?
200.
200 Legos, excellent. Now, what is 40 Legos minus 60 Legos? Or you could just say, what's 4 minus 6?
Do we need to borrow from the 10th place? Because he doesn't know what it is.
Well, what's 4 minus 6?
Do we need to borrow from the 10th place?
Or we can just go to the number line
That's a great idea.
and go backwards.
Pirate's arm.
Yeah, let's do it, Pirate Sam. Start at 4 and let's go backwards.
3.
Close, let's try again. 1, 2, we're gonna go backwards 6 spaces. 4, 5, oh, thanks, Pirate Sam. 6, there we go. So the answer is
Negative 2.
negative 2. So really, this is minus 20 because it's in the tens place. 40 minus 60. All right, and then we have 8 minus 8, which is
0.
0. That's nothing. So really, we're just looking at 200 minus 20. And that's how many Legos we have left over. So what is 200 minus 20?
200 minus 20, I know what that is.
Or what's 20 minus 2?
I can see what 20 minus 2 is. 18.
18. So this is 180 donuts because we are looking at 200 minus 20. That's the final answer. Excellent work, Pirate Sam. All right,
There are 57
In a mouth.
bird poops on the driveway, but 29 have been cleaned up. That means we have still some bird poops to clean up off the driveway. Ew, bird poops. We had 57, we've cleaned up 29. How many are left? 57 minus 29. You got 5 tens, you take away 2 tens, that's 3 tens. 30. But what about 7 minus 9? Ooh, well 7 minus 9, ooh, that's a tough one. 7 minus 9 equals, it's out of the frame. 7 minus 9, let's move the camera. 7 minus 9 is -2. So, we have 30 and -2. 30 and -2. So go backwards from 30 2 times. Let's see. 29, 28. We're subtracting 2. That means we have 28 bird poops left to clean up. Ew. 28 bird poops. -3, -4, -5, -6. Negative numbers just keep going and going and going. That's why we have this concept of infinity and negative infinity. Numbers never ever stop. Hey, Mom, Dad, if you found this information wild, fun, educational, go ahead and buy us a coffee. There's a link down below. See you next time, class. Hey, don't forget, God loves you.
Okay. We have 845. No, Greater Gator, we're not eating people. We have 845 trucks. And Pirate Sam's gonna take away 357 trucks. I don't know why we have as many trucks, but suppose we do. What's 800 minus 300, Pirate Sam? Hey, Pirate Sam, quit fighting Greater Gator. Let's look over here. What's 800 minus 300? Hey, Greater Gator, don't eat the paper. Come on, Greater Gator. What's 800 trucks minus 300 trucks?
Greater Gator.
Yeah, come on, Greater Gator. What's 800 trucks minus 300 trucks? Pirate Sam, do you remember what's 800 minus 300?
800 minus 300. Greater Gator.
Well, what's 8 minus 3, Pirate Sam?
Greater Gator ate 300 from 800, so
No, the Greater Gator's not.
500.
We got 500. The Greater Gator's not going to eat any more trucks. Okay, so we have 500. Now, what about... This is really 40 minus 50. We're in the tens place right now. No, thank you, Pirate Sam, our Greater Gator. This is the tens place. What is 40 minus 50? Or, to make it even simpler, what's 4 minus 5? What's 4 minus 5, Pirate Sam?
Okay.
Pirate Sam and Greater Gator are discussing. If there are 4 trucks, or really 40 trucks, and you take away 50 trucks, how many are left over?
Then -1.
It's -1, but since it's in the tens...
10.
That's right, because it's in the tens place, it's -10. All right, now last but not least, we have 5 ones minus 7 ones. So what's 5 minus 7? That's the tough one.
5 minus 7. Let's make a number line.
All right, you want to make a number line? We can do that. Start at 5, and let's go backwards. Okay, so we're going to go back from 5. How many do we got to go back? We got to go back 7 whole numbers. So 1, 2, 3, 4, 5. That's not enough. We got to go 2 more. 6, 7. So what's that number right there?
-2.
-2. Very good. So we have made this problem 500 minus 10 minus 2.
10 minus 2.
Well, let's do it step by step. What's What's minus 10 and minus 2?
Negative numbers.
It's a negative number, that's right. Or we can go 500 minus 10.
Greater Gator.
The Greater Gator's eating Hezzy's face.
Right, I can see.
All right, Greater Gator, stop eating Hezzy. What's 500? No, don't eat my face. What's 500 minus 10, Greater Gator?
500 minus 10.
Oh, Pirate Sam's gonna help us.
Okay. 500 minus 10. 490.
490, excellent. And then we still have minus 2 left over, Pirate Sam. What's 490 minus 2?
Negative 88.
Not negative 88. What's 90 minus 2?
88.
88. So this is 400. No, thank you, Greater Gator. This is 488 trucks. That's how many trucks we have left over. Greater Gator, stop eating the paper. Come on now. Here, have a PlayStation remote. Last one. We've got 1,000. Banana. What's Banana doing here? We've got 1,056 bananas. Thanks for the bananas. And we're going to subtract 868 bananas. We want to know how many bananas are left over. There is a banana on my head right now. Hey, what's a banana doing on my head? All right, let's put the banana right here. Bananas. Boop. Okay, the bananas are now a part of the problem. So Pirate Sam, let's start in the thousands place here. What is 1,000 minus 800?
1,000 minus 800.
Or you can just ask yourself, what's 10 minus 8?
The Greater Gator's got 10.
Okay. If you have 10 bananas and you take away 8 bananas, how many bananas are left over?
The Greater Gator's gonna.
Hey, the Greater Gator's eating the banana. What is going on here? Okay, so we got 1,000 bananas. Thank you, Greater Gator. And we want to take away 8 bananas. How many are left?
10 minus 8. Or 10 minus 8. 10 minus 8.
All right, Greater Gator. Pirate Sam's turn to help. What is 10 minus 8, Pirate Sam?
10 minus 8. Now the Greater Gator ate 8, so that's 2.
2 or 200. Now let's look at the tens place. That's the tens place right there. Boop. Okay, we have 50 minus 60. Hey, banana, what is 5 minus 6? Do you know, Pirate Sam? Come on, Greater Gator, you gotta move. What's going on here? Hey, what is 5 minus 6? 5 minus 6 is... What is 5 minus 6, Greater Gator? No, it's not a remote. What is 5 minus 6, Pirate Sam? A water bottle? What is going on here? What is 5 minus 6? Banana? No, not a banana. What's 5 minus 6? Pirate Sam is not helping us here. Maybe we'll have to ask Greater Gator if he knows. Greater Gator, do you know what 5 minus 6 is? Pirate Sam is just not helping right now.
Now I know what it is.
Oh, what is it? What's 5 minus 6?
5 minus 6. Well, 1.
Not 1. What's 5 minus 6?
Negative 1.
That's right. And really, this is the tens place, so that's negative 10. Last but not least, what's 6 minus 8?
6 minus 8. Let's make a number line so that the Greater Gator knows what it is.
Okay, let's do it. 6, 5, 4, 3, 2, 1, 0. Let's go backwards. 8 whole numbers. 1, 2, 3, 4, 5, 6. Nope, we gotta go 2 more. That's 6 minus 8. So that whole number is, that integer, not a whole number. Whole numbers are
Negative 2.
positive. So this is negative 2. And that's what's left here. Wait a second, didn't we just do this? We already got this number. Hey, what's going on here? We already got this number in the last problem. What is 200 minus 10? Problem. 200 minus 10 is 190. And then we still have to subtract 2. 190 minus 2 is...
This is 188 bananas.
188 bananas. Banana! Thanks, Grater Gator.
Keenumbers. Keenumbers.
I'm Keenum. Let's talk about how to guess the number.
Stinky shoes.
Stunkish.
That's right. Stinky shoes. What if we have a number of stinky shoes that's odd and bigger than 9, but smaller than 13? We're gonna have to make some space here. Bigger than 9. Well, that's 3 stinky shoes. 4 stinky shoes, but bigger than 13. 5 stinky shoes. 6 stinky shoes. 7 stinky shoes. 8 stinky shoes. 9 stinky shoes. We have to have a number that's bigger than 9, odd, and smaller than 13. Is it 12? I just added 3. No, 12 is an even number. We need an odd number that's bigger than 9 and smaller than 13. Oh! Get rid of a shoe. 11. 11 is an odd number. It's bigger than 9 and it's smaller than 13. Woo!
I'm a double-digit number. I'm a double-digit number. Not 10, not 20, less than 100. I'm a double-digit number. Not even, not odd. Greater than 55, smaller than 99. Can you guess which number I am? I'm a double-digit number. Not 10, not 20, less than 100. I'm a double-digit number. I'm a double-digit number. Maybe I'm 79 or 81. Yeah, that sounds good. Let's say it's 81. Double-digit number. Double-digit numbers?
How about a number of bricks that ends in a 6? That means it has a 6 in the ones place. It's bigger than 20 and smaller than 30. Let's see here. This is 2, 4, 6, 8. If we add 2 more, that's 10 right there. Okay, let's see if we have 10 more. Let's create another stack. Hey, that's 10 more, so that's 20. 10, 20. What about 30? Can we have 30 bricks? No, we said it has to be less than 30. And bigger than 20. So it can't be 30 bricks. That's too much. Has to be bigger than 20, but smaller than 30. And it ends in a 6. So could it be 22? No. 22 ends in a 2, not a 6. Can it be 24? No. 24 ends in a 4, not a 6. Oh, okay, so it needs to be 26. That's bigger than 20, it's smaller than 30, and it ends in a 6. 10, 20, 26. 26 bricks. That's the number.
I am a double-digit number of avocados that's bigger than 81. You say my number when you count by tens.
Well, why do we care about this figure right here, 100?
That's right, 100 is not a double-digit number. It has 3 digits. So we can't work with 100 avocados. And we know that it's bigger than 81. This is what 81 avocados looks like. because it's double digit, that means the biggest it could possibly be is 99. But since we get to the number by counting by tens, that means it has to be something like 50, 60, 70, 80, 90. Oh, that's it! 90, because it's bigger than 81 and smaller than 100. It has to be 90 avocados. Let's look at an even number of blocks. That ends in 4. It has to be less than 43, but greater than 25. Here's 43. 10, 20, 30, 40, and 3. 43 blocks. Okay, it has to be smaller than 43, has to be an even number, and it has to be greater than 25. All right, well, it's an even number, and it's gotta be bigger than 25, and it ends in a 4. Okay, could it be 30? No, 30 ends in a 0. Could it be 32? No, 32 ends in a 2. It has a 2 in the ones place. What about 43? Nope, doesn't end in a 4, and it's an odd number at that. But if you said 34 this whole time, if you've been screaming at the device 34, well, you're correct. It's greater than 25, and it's smaller than 43. It's an even number, 34, and it ends in a 4. 34 blocks. Good job, class. If I'm a number between 10 and 20, and I end in a 5, what number am I? That's right, 15. Good job, class. You know what? God loves you, and he gave you this mind to use for good purposes, for his purposes. And math is just one more tool we have to understand the world around us. Mom, Dad, if you find this stuff helpful, help us grow. There's a link below where you can buy us a coffee. See you next time. Next problem. I'm a double-digit number of train tracks that has a 4 in the tens place. You say my number when you count by 5s, but not by 10s. Well, if we have a double-digit number of train tracks, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 train tracks. And
Minus 1.
hey,
9.
we need 10 train tracks. Can you add one? 10 train tracks. Thank you. It ends, well, we don't know what it ends in, but you can get to it when you count by 5s. Oh, okay, actually, so we do know what it ends in. That means if we can count by 5s, 5, 10, 15, 20, so on and so forth, that means it ends in a 0 or a 5. But we can't get to it by counting by 10s. Wah, wah, wah. That means we cannot get the number of train tracks that we need when we count by 10s. It doesn't end in a 0. This is an advanced problem. Stop and rewind. Pause if you need to. It's a double-digit number. It's not 10 because it has to have a 4 in the tens place. It's not 20 because that has a 2 in the tens place. It's not 30 because that has a 3 in the tens place. And it's not 40. Why? It has a 4 in the tens place, but you can't get to it by counting by 10s. You can get to it by counting by 5s. 45. 45 train tracks. This is a tough number. Wow. If you got this far, class, give yourself a high five.
I'm a double-digit number. Not 10, not 20, not 100 either. I'm a double-digit number. I'm a double-digit number. Not 50 or 55. Praise God, I'm alive. I'm not even, maybe I'm odd. Can you guess what number I am? I'm a double-digit number. I'm a double-digit number. Not 10, not 20, not 100 either. I'm a double-digit number. I'm not 62, I'm not 73. Hey, I'm less than 94. I'm an odd number, can't you see? I'm a double-digit number. Not 10, not 20, not 100 either. I'm a double-digit number. I'm a double-digit number. I'm not 63, I'm not 68. I'm greater than 75, less than 85.